often find when I'm teaching one of these preparation courses, I have to teach in two ways. One's visual, the other is in a sequence. Now, do you remember a face better than a name? If you do, if you remember the face, you probably are more of a visual person. Many people see here a sign, but I see letters. Look closely. I see N, M, maybe even W in there, huh? It's interesting to look at the angles in this logo. What's the average degrees between each of those lines? 360 degrees divided by 6. Each one of those is 60 degrees each angle. Turn a word problem into a picture. Now, here's what they say. Take the sum of all the numbers from 201 to 300. We're talking 201, 202, 203, and we're adding all of those numbers up. We're going to subtract this amount. We're taking away this amount from the sum of 301 to 400. So that sum is, let's have a nice color, 301 plus 302 plus 303, right? Do you see a pattern here? If you lay it out, you can instantly see. They're asking, this is the first one at the bottom, 201 plus 202 plus 203. We're subtracting the sum of 301 plus 302 plus 303. If I just do the first one, subtract the 201, the first difference is 100. If I do 302 minus 202, the difference is 100. Do I have to do the next one? I don't think so. You see it in your mind. So now we just have to count. How many numbers are there from 201 to 300? Well, you have to think this through. Is there 100 or 101? Well, you got 1, and over here, it's 300. So it sounds like you're going to have 100 numbers. If we had said it was from 200 to 300, then you would have had 101 numbers. But here it goes from 201, 202, 203, 204, 205, 206, 209, 210. 10 numbers for the first 10. I think we're in the right direction here. So, we have 100 numbers, and the difference between each one is 100. So I'm going to say the total difference is 100 times 100. How many zeros is that? That's what I get. Here's a tricky kind of problem. They sometimes ask you a problem in algebra. And the silly thing is, this is math, but they've got letters. So they have something that has an X in this problem. But we're not going to worry about the X. We're going to think. Let's substitute something, okay? Now, let's say that apples are 75 cents a pound. They want to know how much will X pounds of apples cost. X pounds of apples will cost 75x or 75x over 100 or 100x over 75. It's all very confusing. But what if we just say, put a number in for X? Let's put a number in. How many is a good number? Shall we say 10 pounds? We're getting 10 pounds of apples. Now if I just asked you, okay,